Hello, everyone, and welcome to another episode of Generative Geek. Today, we are going to discuss how using Chroma DB you can do multimodal ingestion and retrieval. In the past, what we have done is we have covered on loading, transforming, and storing data for RAG applications where we took YouTube videos and PDFs and we then converted them into documents and then stored those documents into ChromaDB for question answering, right? For more sort of a retrieval. Today, I'm introducing images into the fold, and we already had it like a multimodal, but the entire thing when it was saved on ChromaDB was in the form of transcripts or text, right? Now, what we are doing is we are doing a true multimodal. We are not converting it into text, but we are going to use the images and using some sort of a multimodal embedding function, and we are then going to create vector embeddings and store them into Chroma, which will be then used for querying and bringing the results out of Chroma, right? So just to help you understand, earlier videos you have seen me doing some sort of work with mp3s and YouTube videos and then converting them using Whisper into transcripts. Now we are not going to do that. We are going to take the image as is, and then using a multimodal embedding function, we are then going to save that image in ChromaDB and then use retrieval mechanisms to query whatever information we have stored in ChromaDB. So, scope for today's lecture is we are going to learn how to ingest multimodal data, specifically images, into ChromaDB. Then, what we are going to use CLIP for multimodal embedding. I'll cover that in further detail. We are going to use retrieval using a text query. We're going to say, hey, you know what, give me images of dogs, give me images of people with animals, things like that, right? And going to see what kind of images are coming back, right? And then we are also going to say, hey, you know what, take this image and give me all the images from your corpus which are similar to this image, right? So I've already covered in detail. If you have not seen those videos, I highly recommend watching embedding videos where we cover how embedding works and how cosine similarity and distance calculations and things like that are done. So that same mechanism is used for image similarity as well here, right? So the vectors from one image and the vectors from another image are going to be closer. The closest vectors are going to be pulled out and images corresponding to those vectors are going to be shown, right? So let's just get started now. So I'm in my Collab notebook, and if you don't have a Collab Pro, it's perfectly okay. We are not going to use any kind of a GPU service right now. So what I recommend is open your Collab notebook, and the first thing I'm going to do is just change the name of this notebook. I'm going to name it Multimodal ChromaDB Demo.ipynb, and I'm going to make sure that I keep saving this file, and I'll share this notebook as part of the YouTube video description, right? So in your description you will find link to this notebook, right, that we are creating now. So the first thing is, for any time you are here, if you have a pro version, maybe pick a runtime that you are interested in. I'm on a CPU and I can be on a CPU, but because I have credits, I'll just pick a T4 GPU, which is a relatively cheaper one. And then let's just get started with installing some libraries that we will need, right? So for this, what we'll need is, because we're going to work with ChromaDB, so we'll definitely need ChromaDB. We'll also need datasets, but I'll cover all of that in a while, right? So let's just install ChromaDB first. And the reason I'm not installing other libraries is because I want to show you what is the approach I'm taking, right? So for this, while this installation is happening, let me quickly tell you that the data set I'm using for this is Hugging Face ImageNet 1. So let's just ImageNet 1K. So this is the data set that we are going to use. And in order to use this data set, what we'll need is we'll need you to have like tokens, right? The access key for Hugging Face. So what you can do is go to your Hugging Face, go to the settings, and from there you have this access tokens, right? So sorry. And clicking on access tokens will then take us to a screen where we can create a new token, right? So I'll say multimodal Chroma DB. That's the name I'm giving. You can give it any name, and if you give it like a read permission and generate the token, and deliberately I'll be introducing some errors so that those errors, when you see, you can understand how I approach some of these problems, right? So multimodal Chroma DB, and then we'll come here because we want to use this key. the way to use it is you will need, in your Google Colab, go to this secrets like a key icon and create a new key, right? So the key should be called hf underscore token. Now because hf underscore token is already there, what I'll do is I'll first delete this token, right? So I already have one token, I'm going to delete that. I cannot have two same keys. Hf token, and I'm going to paste this token here, and I'm going to give this token the access, right? So when you say, hey, this has access, that means that key or that secret is now available within this notebook, right? So hf underscore token is now available. What I'll also do is now import pip install datasets, right? So that's the library we'll use for accessing Hugging Face datasets. So now our key is all set up. What we'll now go is we'll go back in here and wait for the datasets library to be installed. Once the datasets library is installed, I'm going to make use of the ImageNet 1K. And the way you do it is, okay, so this is also done. So now let's quickly start writing our code. I'll come here, expand this a little bit, import OS, and then we'll say from datasets, import load dataset, right? So this is the function we'll use for loading all of our datasets from Matplotlib, import pyplot as PLT. I'm not importing ChromaDB yet because I'll import it when I'm using it. What I'm doing now is I want to start loading the dataset ImageNet 1K that we just discussed. This is the dataset. If you go here to datasets and you say ImageNet 1K, this is the dataset I'm using. This is a very powerful dataset and it's a fully labeled dataset. What I'm going to do is I'm going to load images from this dataset. You can take any other dataset as well. You can take the Coco dataset that is available. So it's up to you. I'll leave the choice of the dataset selection to you. For this demo and for this tutorial, this lecture, I'm using the ImageNet dataset. So let's say we'll load the image net 1K dataset, and we'll say dataset is equal to load underscore dataset. We'll give it the name. We'll say ImageNet hyphen 1K. We'll say split is equal to train, and we are going to say streaming is equal to true. The reason I'm saying streaming is equal to true is because this is a very large data set, right? This is roughly a 20 gig data set, right? So if I don't give it the streaming equal to true, it is going to wait for the entire data set to be loaded, and we probably for this demo don't need all the million images that it has. I'm going to maybe may work with 500 images or 200 images and show you how you can actually do it, right? That's my goal. So we are going to say streaming is equal to true. And then I'm saying how many images I want to work with. I want to work with roughly, let's say I want to work with 200 images to start with. And there needs to be a folder where I'm going to save these images. So I'm saying, hey, create a folder called images. Right now, you don't see any images folder here. But when this code runs, you will see that the images folder is where I want to save this images, right? So I'm going to say, hey, from the dataset, when you are pulling the images, also save them to a folder, right? The images to folder, and we are going to say, hey, dataset underscore iter is equal to iter dataset. We're going to iterate over the dataset, and we're going to create a directory which is basically the name is image, whatever is the name of this variable. I'm going to basically use the same name, image folder, and we're going to say exist OK is equal to true. uh, so what this will do is if I just run this code now, what this will do is dataset is created dataset. So this is the error, right? So I wanted to come to this error in a while, but this is the error. But I'll discuss this error in a little more detail, right? So till now what we have done is we are working with the load dataset. This is like a standard way of loading datasets from Hugging Space. You basically give the name of the dataset, and then you say streaming is equal to true if you want the streaming function to be available. I'm now saying, hey, from the dataset, now this is for my downstream code. I'm saying, hey, I'll work only with 200 images for now, and I want to save those images in the images folder, right? And I was asking it to create the image folder. But now what happens is ImageNet 1K is a gated repository. And what that means is, if you look at the error, right, as soon as it tried to run this line of code, it's saying, hey, dataset is a gated dataset on hub, you must be authenticated to access it, right? So the way to handle this is, I'll go back to my tokens. So go back to your Hugging Face, go to the settings, and go to your access tokens again. Now this is the token I'm working with, it has read permissions only. So what I'm going to do is, I'm going to okay, I'm going to maybe go in and create a new token called Multimodal uh, Chroma DB, and I'm going to say, hey, this is a fine grained custom one. Now I'm going to set permissions there, right? So the read one could not, and I'm just giving it. You can give it various permissions which you think are, like, easy for you to handle. But the important one is read access to contents of all public gated repos you can access, right? So this one is the most important one. I'm, for the sake of this demo, I'm just giving it all the permissions, and you can then say save. Now it's up to you, when you use this permission, it's up to you how you want to. Which all permissions you want to give. I'm just going to invalidate and refresh once. uh, Copy, close. We can see the permissions again. If all the permissions are there, yes, the permissions are there. And I'm now going to come back here, change the token that I'm working with. I'm just going to change the token, uh, and use the token we just got, right? So and now again, what we'll do is, we'll run the same code again. But before we run the same code again, let's quickly also log into the Hugging Face CLI, right? So the way you do it is, you will type Hugging Face hyphen CLI login, and you will wait for this to run. It says, hey, to log in, Hugging Face Hub requires a token that is generated. Now this point, you should enter the token that you have, your token. So I'm going to come here, paste the same token, press enter. This is still add token as a git credential. Maybe I don't want to do all that, so I'll say no. Your token has been saved, login successful. So now what has happened is, using our token, we have been able to log in. Now from here, you can run this code again, right? So let's just run this code again and see what comes back, right? So we're going to run this code again. Ideally, I could have just waited and wrote more lines of code. Here, if you see, I still don't see. Okay, it is asking for some permission. It's saying, hey, do you want to run some custom code? So I'll say yes. This probably has some custom code, and that's why it's asking me to for yes and no. Um, Okay. And now if I go to the folder, I should see images here, right? So but this is an empty folder right now, because we have not yet started iterating over the data set. We are now going to work on all of that, right? So far, the part where our data set has to be loaded, the gated data set, the token permissions, logging in into Hugging Face using the token, all that is now done, right? So we are now ready for the next steps, which is load, loop through the data set, maybe display the image as well, like, so that we see. And that's why I have Matplotlib that I have imported. I want to show you what the images are that we are getting from the dataset. Once we get those images, we are then going to write them to the folder, and then we'll start working with the Chroma DB part, right? So now what I'll do is, I'll write code for looping through and also plotting, right? So that we can see what kind of images are coming back from this. So we'll say for plotting, and the way I want to plot is, I want to have, like, some columns. So we'll say, hey, I want 5 columns, and we'll calculate how many rows are required, because if I'm working with 200 total images, 200 divided by 5 is the number of rows I'll need. But instead of hard coding, what we'll say, hey, whatever is the n images, divide that by plot calls, and we'll get the number of rows that are required, right? So this becomes my x and y axis of sorts. And then we'll say, hey, we'll then use Matplotlib, and we'll say plt dot subplots. We're going to create subplots and plot underscore rows and plot underscore calls. Our fig size, we're going to give the size to this figure, and we are going to say, hey, plot underscore calls into 2. So that's what I'm giving as the size for the axis, and the other one will be plot underscore rows into 2. So this is going to be like a square. I'm just giving it more like a size, and then we'll flatten the axis, right? So we're going to flatten the axis. Axis is equal to axis dot flatten. So with this, now my code for just the code, that is the skeleton is ready, where this will be now shown, the images are going to be shown, and now I have to actually plot images. So what we'll do is, this is the part where I'm going to now loop through the data set, right? So I'm going to say, hey, for I comma data in enumerate data set, we are going to loop through the data set, and we're going to say, hey, if I is greater than or equal to n underscore images, then we want to basically break, right? Because I don't want to keep going, right? I want to just stop where this has like millions of data points. I'm not going to work with all of them. Like I said earlier, I'm just going to work with whatever is whatever number I want to work with, which is maybe 200, 500, 150, whatever, right? So we're going to say, hey, image is equal to data image. I'm just accepting the suggestions it is giving. So yeah, this looks right. Image is data image. Within the data, I'll have image. Yes. I'll also have label. So I'm accepting that also. And I'm going to accept the IM show, and I'm going to show the image. Yes. Then we are going to set the title. I want the title to be slightly more descriptive. So I'll say, hey, F label, and then we are going to define the label, right? So we are going to say, hey, whatever is the label that I want to define, right? So this is what I want. Next, axis.I.axis off looks okay. And we are going to save the image now, right? So we have shown the image. Now I want to save the image. So we have written the code which will basically save the image, and we are going to say, hey, whatever is this dot jpg, this is where this image is going to be saved, images, and then the I can even say, hey, this should be my image save folder. So this is the images folder. I can, oops, sorry, I can have the image folder here. Whatever is the image folder slash I dot jpg becomes my image dot save, right? So this is going to be saved there. Then I'm just going to come out and say, hey, plt dot tight underscore layout and plt dot show, right? So my code to basically run through the data set, save the images, show the images is ready. Now at this point, I'll just run this cell and see if everything is okay. Uh, Seems to be running. I can even come into the images folder and see if there are any images getting saved here. Yeah, you can already see there are images showing up here. Uh, the This is where the looping part is happening, because the PLT show is outside of the loop. It will show all the images in final go, right? So I can already see all the images are getting saved here. We can see some 180, 190 images. So it seems like the code is about to end. The plotting should come up. Once the plotting comes up, this is the part where you will be able to see the images. Still running, still running. I'm still waiting for it to complete its run. Okay, still running. This can take a little while. What you can do is, maybe I'll just pause the video here, wait for this to come back, and then show you. So okay, the code has run, and you can now see that, we said, hey, 5 columns. So there are 5 columns, and there are number of rows that this thing has, and you can see these are all the images from the data set, right? These are the various images that we are getting. These are the various labels it has. We are also printing the labels here. So you can see, this is, you can see how this code is working. We have the image, we have the I'm just going to say automatic saving has failed. So I'm just going to save this again. Yeah. So, and then once you have this, the notebook has changed outside. I don't know why this is happening. Okay. So, yeah, I'll make it a point to save the notebook before I publish this. I have had that, I have burnt my fingers a little earlier. So now at this point, what we'll do is we now have the images ready. Let's get started with ingesting these images into Chroma DB, right? So for that, what we'll do is we first have to import Chroma DB. We have already installed Chroma DB, but I'm now going to import Chroma DB. And we are going to say, hey, client is equal to, if you have seen my Chroma DB videos, which this is basically a continuation, I'm not creating a persistent client here, but you can even create a persistent client by actually providing the name of the path where you want the database to persist, right? So we create a client, and now what I'm going to do is I'm going to use the OpenCLIP embedding function. Like I have discussed earlier, in order to create any collection on Chroma DB, you need two things. You need a name of the collection, and collection is basically a table, right? So think of it like a table. If you want to create any collection on Chroma DB, you need basically the name of the collection and the embedding function that you are going to use, because these are all vector databases. They are not saving the data as is, they are converting it into a vector. So you have to specify what will be the embedding function, and I'm going to use the OpenCLIP embedding function for this. OpenCLIP embedding function is provided by OpenAI, but this is open source. And I'm going to use the image loader for loading the images into Chroma DB, right? So from utils.data loaders, sorry, not batch utils, from data loaders, from data underscore loaders, import image loader, right? So I'm going to import this, and I'm going to say embedding underscore function is equal to OpenCLIP embedding function. We are going to use this, right? So we're going to use this image underscore loader is equal to image loader. I'm also going to instantiate this. So now our loader is ready, our embedding function is ready. We have to now bring all the images, the OpenCLIP. So it says the OpenCLIP Python package is not installed. So we'll also need to install the OpenCLIP torch package, right? So before we are able to run this, we'll have to install this. So I'm going to say, hey, pip install OpenCLIP torch, right? So we're going to install this library as well, because this is a dependency and it was not able to find this dependency. So once this dependency is done, then I'm going to run this line of code again. This will give us the embedding function and a loader, right? So now once we have this, what we'll do is we'll come here and we'll say, hey, now that the embedding function is there, let's create a collection, right? Or let's just wait for this to get done, and then we'll get started again. So I'll pause this till this library is getting installed, and again come back. So now the library installation is done. We are now going to define the collection, right? So I have the embedding function available, I have a loader. I now need to get started with writing actually the collection, right? So I'm going to say, hey, collection is equal to client dot get or create. Usually you can also see, hey, create underscore collection, but what happens is if you rerun the code, it will give you an error saying, hey, this collection already exists, and therefore I'm using get or create collection. As you would have seen in the previous video, I have already discussed this method. Now what we'll do is we'll define the name. So I'm going to say, hey, name is multimodal collection. That's the name I'm giving to this collection. And we are going to say, hey, embedding underscore function. So this the tooltip is also coming, which is telling you, hey, what is the embedding function that you want to use. I'm using the embedding function as the embedding function. So the name of the variable is embedding function, and I'm also passing the embedding function variable that I've already declared. And we also are required to give the data loader. So I'm saying data loader in my case is image underscore loader, right? So these are the various things. With this, now if I go out and run this code, the collection should get created. And I can even do a client dot list underscore collections to just see what all collections are available, right? So there is a collection available, that I can see. I can say, hey, so there is one collection that is definitely available, right? So what we can even do is I can say, hey, collections is equal to client dot list underscore collections, and then say print collections, right? So if I do this, uh, still getting the same, yeah. So we can see that there is one collection that is available. So what I'll do is I'll quickly now loop through it. So I'll say for call in collections and print call dot name, right? So if I do this, I can see that the collection is called multimodal underscore collection. So this collection is now created. Now let's just get started with basically. So the collection is available. Now let's quickly load the add the images that we have in our image folder. So in our image folder, if you see, there are a lot of images available. Let's just load those images into the collection now. So we're just going to say, hey, image underscore URIs is equal to sorted. And I'm going to say os.path.join and give it image underscore folder. So I'm creating the URL name for to ingest all of these images uh, into Chroma DB, right? So creating a list comprehension. So for image underscore name in os dot list dir image folder. Yeah. So I'm basically looping through each image in the image folder and then creating a image URI that I can use for ingestion into Chroma DB, right? So in the easiest way. So we're going to get the image URIs like this. And then what I'm going to do is I'm going to say, hey, we also need IDs because IDs are not auto generated like I've already discussed. So we're going to say string of I for I in range of len of image underscore URIs, right? So I'm generating a list of numbers and I'm going to give that the IDs. Next step is simple. You will just say collection dot add and you're going to give IDs and you're going to specify what are the URIs, and I'm going to say image underscore URIs, right? So if you remember, our loader is a image loader, right? So you are using an image loader in this case. So it understands how to handle the image URIs. So I'll run this, hoping that there is no error, but no. You must set a data loader on the collection if loading from URIs. Okay, I think something is not right because we had specified a data loader earlier. Data loader is this. Uh, and I'll not specify this. I'll just say collection. Maybe what happened is as part of our prints and all, some collection definition might have got distorted. So I'm rerunning the cells and I have deliberately removed that print. But if you want, we can again write that in a while. Image URIs collection dot add because we have specified the data loader, so that error should not have come. Maybe when we were printing, I mistakenly added some collection or something that I re-referenced that variable name and that caused the problem. So it seems like it is ingesting all the images into Chroma DB. Once the ingestion is done, what we can quickly do is we can say, hey, collection.count and see how many objects are there in the collection, right? So let it run and I'll come back as soon as this is done. So this is done and I can see that, collection.count is giving me 200. That means 200 objects are now inserted into Chroma DB, right? So now let's quickly write code where I'm going to say, hey, I want to query now, I want to query this collection for some text. So the way to do it is we are going to say, hey, there is a variable called retrieved and I'm saying collection.query. You specify what text you are querying with, right? So this is the text driven which I had already discussed, that we are going to take text. We are going to do text driven searches. We are going to do image similarity searches. So now we have already ingested our data set. We are now doing, hey, query text is animals include data and I want to show 3 results, right? So let's see what comes back. But if you want to really display those images, we'll have to again loop through, right? So through the retrieved data. So we are going to say, hey, for img in retrieved, and we are going to take the data and I'm going to take the 0th element in that, and we are going to say, hey, plt dot img show image, same way like we showed the images earlier. I'm doing the same thing, but maybe in a I'm not displaying all the labels and everything right now. I'm just displaying the image and we're going to say plt dot show, right? So we are saying, hey, my query text is animals and whatever has no attribute img show. Okay, it should be im show, not img show. So plt.im show image. So I said my query is animals, and these are the images that I'm getting back from the data set. From the 200 images that I had ingested, these are the three results that have come back. And now if I change the results to, let's say, 5, so we can do that. I have just changed the results to 5, and now 5 results should be displayed. So let's see. The first is this dog, or is it a dog or is it a hyena, right? Something. But these are all images of animals, right? So you see now the 5 results have come back. So this is about when you have like a simple query where you're saying, hey, animals, right? Now let's just say if I want to change this to, or let me do this. Let me just take this code and convert it into a function. So I'll say uh, def show results, and I'm going to use this because now I can then copy whatever I'm getting from here, right? So I can just copy this function. I can call this function, and so I only need to change my retrieved, and I can then keep calling this function. So let's just say this is my code retrieved. I can then say, hey, show underscore results, and pass it retrieved, right? So now it should again similarly just give me the 5 prints. Okay, it is now showing me those 5 images, right? So my function is working fine. What I'll now do is I'll just keep changing the retrieved. So I've already shown you how to do it with animals. Now let's just say I only want vehicles, right? So I can say, hey, vehicles, and retrieved is there. I just need to call the function. I forgot to pass the show results. So we'll just say show results retrieved. This time I'm querying for vehicles. So you can see I'm starting to get all the vehicles. The cell is still running. These are the vehicles that it has found, and I'm getting all the vehicles, right? So I can even say, hey, you know what? Let's quickly search for some sort of a habitat for natural habitat. So till now it was like a one word query. Now I'm saying, hey, natural habitat for flora and fauna, more complex query. And now let's just see what it shows. Keep forgetting the name of the function. It's show results. um, Show results retrieved. So now let's see what comes back, because now it will take this use clip embedding function and then again convert it into a vector and find which are the vectors that are most closest to this, right? So you can see I'm seeing some sort of a wild flora fauna, a natural sort of a habitat. My results were 3 this time, but let's just make them 5 and see what comes back. But you can see how beautifully it is working with all of these queries. Now, if you have a multimodal RAG setup, and maybe a query comes in where an image is presented, or maybe an image corpus has to be searched, you can convert them. Sorry, you can convert them using some sort of a clip embedding or a multimodal embedding function, and then search through your database, right? So this is what it is. Now let's come to the last part of this lecture, where I want to or maybe let's do one more, right? So maybe I'll just do some sort of two things where I'm saying, hey, humans and with animals, or humans with cars or vehicles, something like that. But let's just say humans with animals. So show results retrieved, and let's see what comes back, right? So humans with animals. I'm just showing different images. So you can see, it is now returning back humans, where the humans are shown with images. Make it 5. And this is when we only have like 200 images that we are working with. See, this data set has millions of images. If you expand your scope, go up to like 5,000 images and see what comes back, you will be very impressed with the results you get, right? So these are like humans with animals, and like, see how spot on it is. There is a human, there is a, and can we say, hey, humans with animals, instead of humans with animals, just say humans with dog, right? Human with dog. So let's see what comes back, right? It's even more specific. Animal is still a more generic label, but this human with dog, except for one image, because I'm only working with 3 images here with 200 images. maybe in my data set there are not enough human and dog, but because we are asking for 5, it is giving me those 5 closest vectors. The way to look at it is that, hey, these are closest vectors. In your reg application, you can probably just pick the highest rated one and say, hey, you know what, this is what I got, and the answers could will still be really good, right? So it's up to you how you want to handle and how rich your corpus is, right? So now let's get to the last step where we're going to say, hey, can we give it a query image? So we'll give it a query image and search for similar images. um, right? So give a query image and search for similar images. So for this, what we'll do is we'll say, hey, from PIL import image, and I'm going to import numpy as np, and we are going to say, hey, query underscore image. So I'm going to just pick one of the images from this folder. So I have like several images here. I'm just going to pick randomly one image, and we're going to say, hey, if this is my query image, can you tell me which are the other similar images from the corpus, right? So from the data set. So I'm just taking some image. We're going to say, hey, image underscore folder. I'm building the path for opening the image. And this is where I'm just going to say, maybe let's pick 2.jpg, right? So I'm just hard coding this. We're saying, hey, 2.jpg. And I'm just going to say, hey, this is my query image. And we'll just show the image as well. So we'll say, hey, plt.im show query underscore image access of plt.show. So let's just quickly run this so that we know what is our query image. So this is my query image, right? So 2.jpg is this bird. Now what we'll do is we'll say print results. So I'm just going to send this query to the Chroma DB and see what results come back, right? So we are going to say again same way, retrieved is collection query, but instead of query text, we are going to use query underscore images. So we were using query text. Now we are going to use query underscore images, and you can pass. It's like it's a list, right? So you can pass a complete list to it. You can have like multiple images. I'm using one for now, but you can have like more images here. So you will say, hey, what are the? It's a list you are passing. So if there are like query image one, query image two, you will pass that. Sorry, you will pass that. In our case, it's only one image, so I'm just passing query underscore image, but this is a list. So feel free to include your lists here. End results is 5. Uh, and always remember, the first result will be the closest match it has in the corpus, right? Which is, if I'm giving this bird, if the bird exists in the corpus, that is going to be the closest match. So if you are asking for 5 images, 4 only are going to get returned in a way, right? Because your query image and the first answer are largely same, right? So, and what I can do is then I can say, hey, show results retrieved. Okay, let's just see this, right? So I hope this is clear till now. So let's just run this and see what comes back, right? So my query image is this, and I'm waiting for the results to show up now. This is this bird image we have given as a query, and I'm waiting for the results. So if you see the query, the first answer, like I was saying, the first answer is same, right? So this was my query result, query image, and this is the first answer because there's a 100% match, right? So these two vectors are like closest to each other, and then you can see other bird images, right? So these are the other bird images. Now maybe I'll just change this from 2 to maybe 165, right? I don't even know how that image looks like, but let's just run this, right? So it's this vehicle. This is my, and maybe it is going to show other cars, right? Or other jeeps or other okay, interesting. It's also showing me what is very very interesting and very funny in a way. It is showing me these two images are all right, but then I see some animals showing up, right? And I don't know why these animals are showing up, but for some reason these vectors are closest right now, right? Now that's a different problem because this image is still more closer, at least contextually, to this jeep, right? We'll just take another one. We'll say 135. I don't know what that image is, but let's see. 135 is okay, some sort of a machine. Lawnmower, no, some sort of an axe or a saw, right? But this saw and this wood probably are connected somehow, or maybe it says, hey, this is also a machine. uh, and there are these levers. So interesting. When you look at context, right, you are not looking for similars in terms of just the features, but also in terms of context. Now this can also be used to saw the wood, or chisel the wood, or whatever it is called. I'm not a woodman myself, or a carpenter myself. Same with this, there are similarities of sorts, right? So this is it, guys. I hope this was fun. Maybe I'll just take one more just for the fun sake. uh, Maybe let's take 96. Let's see what 96 is. Yeah. And so yeah, seems like some sort of a marriage, or some sort of a religious procession, or something. Always remember the first image is the same one, so you might want to skip that if you want. uh, the second one looks similar to it, in the sense there is some crown that this guy is wearing, and they are also wearing something on their head. um, yeah, interesting, right? So it probably also is showing a church here, so which is interesting. um, so this is it. This is what I wanted to talk about. Maybe one more thing where we have one last thing. So till now what we did is we opened the image and we passed that image as a query image. I can even pass URIs themselves, right? So we can even have that, hey, instead of the image as such, I can have query underscore URI, and we can say, hey, image underscore URIs, I'm just taking the first one. And we'll then say query result is collection dot query underscore URIs. And so you are saying query underscore URIs. In the previous one you did image, query underscore images, and here you said query underscore text. So there are like these three different arguments that we have seen here today. There is a query text, there is a query image, and there is a query underscore URI, right? And where you pass the query URI. In our case, I'm just taking the first one right now. Include data end results is 5. And then same way I can just say, show results query result, right? So instead of retrieve, this time it is query result. Um and you just run this, so you see, hey, this is how it is giving you all the images, right? So it's giving you what was the query and what are the various answers it is getting. Now, given the fact that the first result is generally the closest, if you print this query URI, you will see that this is exactly what we passed, right? So the first one is what we passed. uh, and we are getting, for this comics or maybe some magazines, we are getting some sort of a store. Maybe there's some Halloween thing in this here, from where it is getting the context. Um, and because the corpus is also very small right now, so some there will be more noise. But if you go out and increase this number of images to maybe 10,000, you will see very different and maybe much more enriched images. That will be, that is an example for you. So if you go here and say, hey, I want to work with, where we define the number of images, I want to work with maybe 2000 images, right? So, and don't plot them then, right? You don't need to plot them, or you can just say, hey, plot only. You can have another variable here which will be like, hey, plot only 5 images. You don't need to plot all the images. Then that way, or you can completely skip plotting and have like 2000 images ingested, and see and work with it and see how it all goes. I hope you learned something new, and if you did, and if you like this session, do like my video, do share, do subscribe, do comment. It all helps my little channel grow, and keeps me motivated to bring such new content to you every time. Thank you so much for your time, and have a good one.